Today, we're going to examine the quadratic formula. First of all, if ax squared plus bx plus c equals 0, which is our standard form of a quadratic, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Please hold your applause. Okay, so that's a little melody that I learned to help me memorize it. Before we use it, let's first solve by factoring, then completing the square. Then we'll jump into the quadratic formula. So first of all, if we would like to solve by factoring, remember we put c on top, b on the bottom. We look for two numbers that multiply to negative 12 but add up to 4. So 2 times 6, negative on the 2, that should work. So we have x minus 2, x plus 6, which gives us 2 and negative 6. Alrighty, and that sure seems like a fast way of solving that quadratic. Now, let's solve the same quadratic, but this time by completing the square. So, when we look at this equation, remember we want to put the original c on the other side, so the negative 12 becomes positive 12. Half of b is 2, and 2 squared is 4. Keep balance. Remember in the last lesson, whatever you do to one side, you have to do to the other. Absolute value of x plus 2 equals 4. Remove those bars, plus or minus on the other side. And so now we have negative 2 plus or minus 4. So if we look at the plus sign, we get x equals negative 2 plus 4, which gives us 2. No extraneous solutions for quadratics, so we don't have to double check. We could, just to make sure our arithmetic is good. Now we look at the negative sign, and that gives us negative 6. So, as you can see, that's what we got solving it by factoring. Same solution, but it took a lot longer this time. Now, let's do the same exact problem with the quadratic formula. And if we do it correctly, we'll get the same results. So, let's remember the quadratic formula. If we're in standard form, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2. Okay, so here I can see a equals 1, b equals 4, and c equals a negative 12. Watch those signs. So now I'm going to plug in a, b, and c into this formula. So here we go. Negative 4 goes in for b, plus or minus. And now you'll notice that I always put everything in parentheses. Just helps me not make as many careless errors. And on the denominator, 2a. Okay, so here I'm looking at negative 4 plus or minus square root of 16. Negative times negative is going to give me a positive 48. Watch those signs. That's usually where mistakes can occur. So here I'm looking at negative 4 plus or minus, that's 64 over 2. So x equals negative 4 plus or minus 8 over 2. So I want to simplify with the plus sign. That gives me 4 over 2 is 2. And I'd like to simplify again using the minus sign. So that gives me negative 4 minus 8 over 2. Negative 12 over 2 gives me my negative 6. And for sure, those are the same results that we had when we did it the other two ways. I'd definitely say that factoring was the quickest for this particular quadratic. As you get more experience and more practice, what you're going to notice is that sometimes different methods are faster. Not always factoring, and remember, everything's not factorable, like this next quadratic. It's not factorable at all. So let's use the quadratic formula. And I'm going to write it again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. While I like singing, I did that because I want to help burn that into your memory. Every time you write it, when you do your homework tonight, I'd like for you to say it or sing it aloud. So before I can establish A, B, and C, I want to make sure this is put in the correct order. So I want to start with my x squared, move the x term over, and make sure this is set equal to 0. So we can see A is 2, B is 7, and C is 4. So now I'm going to begin plugging everything in. Be careful with that 4ac. A lot of mistakes occur there. So let's see. Negative 7 plus or minus the square root. That looks like 49. That's going to be 8 times 4 minus 32 all over 4. So negative 7 plus or minus the square root of 17 over 4. Now we're actually done here. This is what x equals. We can't go any further. It won't reduce, and the radical 17 won't simplify. So at this point, we just stop. Let's do another problem. Just trying to get some practice here. So A is 1, B is negative 8, and C equals 25. Also, I can quickly see it's not factorable anyway. X equals negative a negative b. Ooh, be careful there. Plus or minus the square root of negative 8 squared minus 4ac all over 2a. So now I see I have positive 8. And when you square a negative, it's positive anyway. Minus 100. Ooh, that's going to end up negative under the radical. Negative 36. And remember, that gives us an imaginary number. So that's 6i. Now, although we can't combine the 8 and the 6i, we must continue to simplify because I can see that there's a common factor of 2 in all of these numbers. So we have two ways that we can proceed with simplifying. And we want to take our time here. One method for simplifying is to split, okay? And this is the method that I suggest. You give both parts of the numerator the common denominator, but split it apart and then reduce them individually. This is the best way to do it. Okay, I noticed the least amount of mistakes are made this way. The other way can be a little quicker. Okay, so if you take that same thing and here's the other method. And so this time, all we really want to do is notice that they all have common factors. Let me change colors here. So notice that all three of these are divisible by 2. And in this case, because they are all divisible by 2, we can simply divide them all by 2. And we get 4, because 8 divided by 2 is 4. 6 divided by 2 is 3. And 2 divided by 2 is 1. We don't need the 1. And you can see that it's the same solution. And normally, this is a lot faster. However, I definitely want to give you a warning. And sometimes I don't like to do this, but I gotta caution you. What's that little symbol they use for the caution with the little exclamation point? Caution. This is what students will often do. They'll take that 8 plus 6i over 2 and just try to do this and say that the answer is 4 plus 6i. I hope you can see the error in that if you do this, you're only giving the 2 to the 8, but this 2 belongs to both parts of the numerator, not just the 8. So this is wrong, wrong, wrong. You don't want to do that. Okay. Just want to prevent that before it happens. Okay, let's solve another one. Before we solve, we want to make sure we combine like terms. So I'm going to I'm going to subtract 3x from both sides. And I'm going to bring the 4 over to the other side. So we cleared that out and we got our 0. I also want to make sure I put it from the largest exponent. Moving on down to the constant term. I'm going to solve it like this, but I will tell you personally, I would multiply by -1. I just like my leading coefficient positive. So personally, I would do this and solve that same exact quadratic. They're equivalent and you're going to get the same answer. But I do want to make sure you know how to deal with the negative. So I am going to do it this way. So A is -7, B is 2, and C is -4. So X equals -b plus or minus the square root of 2 squared minus 4 times -7 times -4 all over 2 times -7. Okay. So we've got quite a bit of simplifying to do here. -2 plus or minus the square root of 4 minus. And if we multiply all of this out, we'll see that that's 112 all over -14. And we can continue to reduce and simplify. The square root of -108. Ooh, I can see that's going to be imaginary. So, a little sidebar. Remember, we want to find a perfect square. 4, 9, 16, 25, 36, 49. I want the largest one that goes in evenly. And it happens to be 36. times 3 times negative 1. So now I can simplify that to 6i radical 3. So I'm going to continue on, and I have negative 2 plus or minus 6i radical 3 all over a negative 14. So now I'm faced with reducing. Again, the safe way to reduce is to just split it up. So this first part reduces to 1/7. Negative over negative is positive. So that goes away. And also, this goes away because we're going to get both signs anyway. So we don't need the negative. So now, let's see. I can reduce this part. 2 goes into the numerator 3 times. And 2 goes into the denominator twice. You can leave the answer like this, or since we have common denominators, you could mush it together. Alrighty, example last. Since, in my opinion, the hardest part of quadratic formula is the simplifying, let's just practice simplifying a few expressions that could result. So, first of all, the square root of 80. Let's see, 4, 9, 16. Oh, yeah, 16 goes into there. That would be 16 times 5. So that's going to give me 4 radical 5. And I'm just going to go ahead and split it now, since they're both over 2. And I get 5 plus or minus 2 radical 5. Okay. Let's do one more. Notice here, these are the 3 numbers that you want to pay attention to. There's no common factor for all 3 of them. So, you don't have to reduce. You don't have to. However, it would be equivalent if you wanted to split it. And the reason I want to show you this is because sometimes you're taking multiple choice and they might have it written a different way. So you need to recognize the different ways that an answer could be delivered. They're equivalent, okay? However, personally, I would just leave it alone. I would definitely leave it alone. But either of these are the same thing, okay? So this is definitely equivalent.